Good morning. I'm Thayne McCombs. I'm a software engineer at Lucid Software, which is located in Salt Lake City. Today I'm going to be talking about an XML library for Scala to deserialize XML documents into Scala data structures. So for a little bit of background, a couple of summers ago, we worked on implementing Indesign import, where we would import Indesign IDML files into Lucidpress's JSON-based document format. So IDML files are essentially just a zip file that contains a whole bunch of XML files inside of it containing the actual data for the documents. So we needed to convert from XML into Scala objects and then perform some transformations on that and then serialize it into JSON. So for our first attempt, we simply used the built-in Scala XML library to access the elements of the XML document. And then we would convert those strings into whatever types we needed and perform validation on that, which worked okay, but we started to notice that we started doing the same things over and over again and wanted to consolidate that. So the sort of things that we wanted to make better is validating the content, so making sure that the XML was the way we expected it to be, handling optional values, being able to convert non-string values into, or convert non-string values from the strings easily. And then also an important thing for us is we wanted to be lenient with bad XML, but still keep track of the errors, so that if the user gave us a malformed document, we could still convert it into a Lucidpress document, but tell them what errors we encountered so they can know that it maybe didn't import correctly. So at Lucid, all of our services are Play Scala services. So we had some experience with the Play JSON library, and we sort of wanted something similar to that, but for working with XML instead of JSON. So after looking around and not really finding anything that really met our needs, we decided to create it ourselves. And we've open sourced that, and it's available on GitHub and Maven Central. So Xtract has 4 main parts to it. The first part is at the XPath class, which represents paths in XML. It's a way to address specific nodes or sequences of nodes in an XML document. ParseResult, which is a monad that contains a result or a list of errors. It's very similar to like try or option for representing the result of a operation. The XmlReader, which is really the heart of the library, which is just an object that describes how to parse a chunk of XML into a Scala object. And then finally, some combinator syntax, which allows you to combine a whole bunch of smaller XML readers into a more complex XML reader. Yep. So XPath, okay, there we go. It's based on the XPath syntax, but it's a little bit different, partly because of limitations of Scala syntax. So we can't use double / as an operator because that is the comment delimiter in Scala. And then we use parentheses instead of square brackets because that's how you do indexing in Scala. So for the single / you can access child elements. A double / you can access descendants. With parentheses, you can access the nth element of a list of elements. / allows you to access an attribute of an element. The with adder methods can be used to filter based on an attribute of an element, so either elements that contain an attribute or contain a specific value for an attribute. Children just gets a list of all of the children of an element. And then finally, the read method allows you to take an XML path and then pass it an XmlReader, and it will apply that reader at that path. So it will essentially find the element at the path that you specify and then apply the reader to transformation at that specific path to get an overall reader that converts the doc, that will parse that specific path. The ParseResult is a sealed trait with 3 case classes: success, failure, and partial success. So success and failure are pretty straightforward. A success wraps a successfully parsed value. A failure, it contains a list of errors that were encountered. And then a partial success has both a successful value and a list of errors that were encountered, so that you can keep track of errors but still give a successful value. And like I mentioned before, it's similar to an option or try. You can convert it to option with the toOption method. And it also implements methods like filter, flat map, map, etc. So you can operate on it like that. The XmlReader is essentially just a function that converts a node sequence, which is the base type for elements or list of elements in the Scala XML library. So it's a function that takes the node sequence and returns a parse result. But the object also defines additional methods like map, flat map, compose, etc. And then the Xtract library provides many predefined readers for things like int, long, option, Boolean, sequences, basically all of your basic Scala types. So here's some sample XML that we'll be using in the sample code that I'm about to show you. So it's just some XML representing a blog post. So it has some metadata in the head. We have some attributes. And some tags. All right. I have a sample project. So in this main method, all I'm doing is I call XmlReader. Can you see that? Do I need to make it bigger? Okay. enough? Okay. So this XmlReader.ofBlog will try to find an implicit value of the type XmlReader blog. And then we're calling read on it is the method which will actually transform the XML into the blog type. And so this here returns a parse result of type blog. And then we just print that out here. In a real application, you would probably use pattern matching to extract the actual value that you wanted, or handle the errors as the case may be. Oh, no, not that one. All right. So on the companion object for the blog case class, I've defined a implicit reader or implicit val of type XmlReader blog. And this is how the XmlReader.of method found the implicit object. So a typical use case is to define an implicit reader on the companion object for the type that you want to read, so that it can be found by Scala's implicit lookup. So there's a couple of imports that are important to have when you're defining the readers. So the XmlReader class object, obviously, so you can define the types. Also, this double underscore here, similar to in Play's JSON library, the double underscore is used to represent the root of the XML document. So you can create XML paths by starting from double underscore and then traversing down. Importing underscore from XmlReader gives you all of the predefined XmlReader instances, which are mostly implicit values. And then finally, importing play API libs functional.syntax.underscore provides some implicit defs that allow you to use some special syntax to create XML readers. So if we look at the reader for blog, basically what I do is I create a whole bunch of smaller XML readers and then combine them by using this AND operator. So combining them with the AND operator creates a builder object, which then has an apply method on it, which you pass a function, which takes a number of parameters that have the count and types equal to the providers or the XML readers that are provided with the AND keyword, and then converts those parameters into the desired type. So in this case, we just pass it the apply method on the companion object for blog, which is essentially the constructor for blog. So it takes the values for each property in blog and creates a blog object from them. We use the XPath syntax here. So for example, the first one, we take the root of the document, then we get the head element of that, and then the title element of that. And then we call .read of type string, and this will find an implicit XML reader of type string, and use that to parse the title. There's if you called an optional on it, then if the element is missing, then it will return in none, and then of course it wraps it in a sum if it is there. Similarly, the default method will provide a default value if an element is missing. This attribute method allows you to specify you want a specific attribute. It's a sort of a shorthand for using double underscore \@ and then the type. And then you pass it a XmlReader. And the enum method allows you to parse an enumeration using the with name method. You can also use for comprehension syntax. So here we are using an XmlReader for the first name and the last name. And then since we use this for comprehension, it will succeed if both the first and last names are parsed successfully, but if either of them fails, then it will fail, and then it concatenates the two together. And then here we're defining a name reader of type string, so we explicitly use a string name reader, a string XML reader here, rather than using the implicit one that's predefined. You can also use the sequence method to read a sequence of elements. And again, this will implicitly find an XML reader of type section and then apply them to each element in a list of elements. So here we're getting all of the sections and applying the section reader to each of them. And then we call map here. So we take each so that we can convert all of those sections into, or we convert the sequence of sections into a content, which is just wrapping a sequence of sections. Any questions on that? Okay. So finally, for a partial parse success, the typical way that you create it is with recover, where you pass it a defaults value. And the sequence also by default will create a partial parse success, and you can use a strict sequence instead if you want it to fail if any of the sub-elements are invalid. And recover works a lot like the default method, but it will store an error if the parsing fails, and continue with that. If you want to define a XML reader for a recursive type, then you use lazy read, which uses by name semantics to enable you to define a reader in terms of itself. And then finally, moving forward, I'm planning on changing it to use cats instead of the play XML library or play functional syntax library, because it's a lot better documented and better understood. So, any questions? Yeah.
How do you handle homomorphic types? Like you might have a sealed trait with different implementations, kind of like derived products for play JSON. Do you support something like that? Let's say I need to receive a sequence of a type which is a sealed trait, and I have a different implementations which have different fields, right?
Right.
So how do you do this automatically, or I have to provide readers for each type that I define?
Yeah, so the way you would do that is you would define a reader for the type, for like the sealed trait. You could provide a single reader for that. or yeah, he would provide us, or you could provide separate readers for each of the case classes. But typically, you define an XmlReader for the sealed trait, and then you would, if it was implicit, it could automatically find that when you use the sequence, or you could explicitly pass it into the sequence function.
Sure, but in that reader, how do I figure out which one to use?
So you can also define XML readers as a function that converts that gets passed in a node sequence and returns a parse result. So depending on how you determined which instance of or which case class to use for that trait, you could put that logic in the function and then use that to figure out which trait class to use. Right. Thanks.
All right, thank you very much.